and this is my presentation on software engineering and a few other topics. This is the board of directors. I don't know why I put this as a slide in. I'm pretty sure you guys all know who you are. I hope so. What is a software engineer? A software engineer is someone who designs and maintains software, often company-specific software.
Slow down.
Often company-specific software. I find this career interesting because I like programming. To do this job, you need to be good at sorting through lots of information and code. Some of the skills needed are patience and a good memory. It's a job probably found in the IT cluster according to WorkBC. Probably. What kind of education do I need to get this job? Computer engineers are required to complete a bachelor's degree in computer engineering and an appropriate related discipline. And they also must be registered by a professional association which registers computer engineers. Other training may include participation in an undergraduate or co-op program, a network certificate, or a master's or doctoral degree in a related discipline. Once the academic qualifications are met, a computer engineering graduate can apply for an engineer in training membership through the Association of Professional Engineers and Geoscientists of BC, APE-GBC, while acquiring the 4 years of experience that is required to register as a professional engineer. Where can I get that education? Most software engineering and computer science courses are offered at pretty much any university. Me, myself, I would most likely be going to TRU since it is the cheapest option for me. As I stated, though, nearly every university has one of these programs, so finding somewhere to go is not the hard part. Going there is. Salary and responsibility. All this information is according to WorkBC, and I'm pretty sure it's not accurate. The entry wage, which is fresh out of university, is, according to them, $50,000 to $75,000 a year. The median wage, the average wage, is $75,000 to $110,000. To get that, you need more experience. And the senior wage is $110,000 to $200,000. And according to that, all you need is more experience. There's not much training you need to go through, any training courses. It's all just practice and memorizing your coding languages. This is the BC labor market outlook for 2018 to 2028. Here we have the forecasted average employment growth and the expected job openings over the next 10 years, and the composition of job openings. You can see here all the information of who's getting hired, and unfortunately it's pretty vague, but they wanted me to include this for some reason. Salary and responsibility, part 2. Some of your responsibilities now will be to analyze user and client requirements for computer hardware and software. You will also have to be able to design your software, architecture, databases, all that stuff. You gotta know how to make that and make it work on the hardware that whoever is paying for this is using. Because most computers are different and similar at the same time for what they can and can't do. You also must be able to research, design, and develop and integrate different systems and telecommunications hardware such as microprocessors, integrated circuit boards, and semiconductor lasers. Apparently, this is WorkBC. I'm still not sure and much of the WorkBC is accurate. You also must be able to supervise, inspect, and provide design support during the manufacturing, installation, and implementation of the computer and telecommunications hardware. Establishing and maintaining relationships with suppliers and clients may lead and coordinate teams of engineers, technologists, technicians, and drafters in the design and development of computer and telecommunications hardware. Community and finance. Currently one of the best places in the world, one of the best places in North America to work is in Seattle, Washington. The majority of the software engineer jobs are in North America on the West Coast, actually. And if I could pick anywhere to live and work, it would probably be San Francisco. Unfortunately, it costs around $5,000 to $12,000 a month, or $144,000 a year to rent there. I can't afford that. And right here is a spreadsheet of my university living expenses. I needed to put that in there somewhere, but it doesn't do much. Benefits and hazards. Benefits. The rate of pay is great. The skills are transferable. You can work pretty much anywhere. It is generally a comfortable working environment since you have a lot of freedom with what you can do with it. There is a constant learning curve, and you can usually be as creative as you want or as creative as you can be. Some of the hazards. Thrombosis, heart disease, cancer, carpal tunnel, vitamin D deficiency, bacterial infections, anxiety, stress, and depression, and insomnia. Most of these are pretty vague. It's all I could think of because there is not many specific hazards for this job, which is a good thing. The work environment. Computer engineers, excluding software engineers and designers, mostly work in the information and technology IT laboratories and offices. These workers typically work 40 hours per week. However, solving some problems or working to deadlines may require extra hours. These engineers may also work with engineers and designers in other disciplines, i.e. computer engineers in BC may work with oceanographers to collect marine and environmental data, or in a wide variety of other cultures. Some computer engineering tasks require the hands-on building of systems, installation and testing, and close vision work. This work is team-oriented and cross-disciplinary, requiring close work with other IT professionals, managers, and consumers. Industry insight. New growth in the industry resulting from rapidly evolving technologies coupled with fewer graduates from software engineering programs is causing a shortage of skilled professionals to fill the openings that arise. Industry sources report that, however, that although there is a shortage of software engineering graduates, there appears to be a surplus of software technologists. Small companies will require software engineers to have broad sets of skills and be proficient in many computer languages. They will also require employees to have computer hardware knowledge and additional engineering knowledge outside of the software realm. Since approximately 3/4 of the computer industry businesses in the province are small employers, demand will be high for those professionals who have a broad education and flexible skills. These engineering occupations require constant updating of skills as technology advances in software development. Now for my creative piece. For this section, we were told to make something that related to our job. I made two kinds of things. I made a video game, which requires coding, and a graphic 3D art piece, which requires computer skills. The game I made, it is called Snake. It's a very old game, a game where you travel around the screen and get bigger by eating circles of food around the screen. If your snake runs into itself or a wall, it dies instantly. I also made art. This is one of the dumbest pieces I made. It's a knife with a scope on it. I made it as a joke, and I figured I should put it in the presentation because it is a very good demonstration of my skills, actually. I was able to complete this one in 3 days, I think. It is made using only 8 shapes on the Blender software that I used. The blade and the blade guard there are 2 pieces, the handle is 1 piece, and then the scope is all the remaining pieces with the screws, the base, and the scope itself. That took 3 days in total to make, not including the materials. That was a different step that took a long time to make. The blade there, with all the different colors and spotting on it, is a custom material that I made for this project, alongside with the handle up there itself too. Those both required me to learn how to make materials in Blender.
When you say materials, I'm going to interrupt, that means how to give it the shading and the texturing and the contouring, right?
That is texturing.
Okay.
Materials is just the color part.
Okay.
Yeah, the shading was all done with a sun that I had up in the corner up there.
Alright.
Yeah.
Thanks.
Because Blender takes care of all the lighting itself, unless you tell it not to, because Blender's lighting isn't that great. Here is my most recent project, a spaceship from the Halo series of video games. I've currently put 2 days of work into this, and as you can see, it is still in very rough shape. At the moment, it is only actually made of 2 pieces. The top section of the ship there, and the bottom. Those are each 2 separate pieces that I carved out, turned into 3D, and stuck them together with Blender's glue. joining them into one piece. And this right here is my favorite piece that I made. It is a forest scene with a snowman, a fire, and a log bench, along with some really nice looking pine trees actually. Those pine trees aren't actually part of the background. Each one of those is a piece that I made. Unfortunately, they are all the same piece, copy and pasted, because the project for this was to make something nice in one day. So I made it in one day, but I wasn't able to add as much to it as I would have liked to. And this here is the video of my game Snake, and what would have been me showing off the code, but unfortunately Google Slides compressed the video really badly so you can't read my code. But maybe that's for the better. I went game over right there because I forgot the controls that I made myself. Your goal is to collect the food and get your score up as high as you can without running into yourself or dying. One thing I forgot to program in was the snake can actually do a complete 180 and run into itself that way, which is really bad because you're not supposed to be able to do a complete 180 in one grid square, because that kills you instantly. And in the original version, I did it right there actually, because when you do the 180, the next update will say your snake ran into something and it ends right there. The controls are really responsive, and the game gets really fast as you'll see in some of the higher points from 5 on. I think the highest I got to was maybe 8 before I finished on that. And that was the final run, and here's a quick overview of all of the code I made. I made this in very few scripts, but unfortunately you can't read them. That blank script there, that only exists because the other code called on it. It doesn't actually need to do anything, which is really neat. It's kind of like Jenga, how you have blocks there, you can take some out, but if you take the wrong ones out, everything breaks. You don't want to do that. Some of the challenges and things I learned while making this was, 1, C is a terrible language to program in, so I made this in Java. And some of the issues I ran into was C is a terrible language to program in. So I decided to make this in Java, and that worked way better. Instead of spending the whole time making one terrible game, I made one half-decent game that works all the time. I am yet to find a time when this doesn't work, which is pretty good, I'd say. Then again, this is a super simple game, and most of my time spent was actually polishing this, because adding any features would, like that Jenga tower, most likely break everything. That is my presentation. Thank you for coming and listening.
Wow. Very good.